Hello everyone, I am T. Ramesh, Assistant Professor, Department of Mathematics of Dr. SNS Rajarajan College of Arts and Science. In this lecture series video, we are going to discuss about introduction of probability. Let's go to the video. So first, what is probability? Probability deals certain and uncertainty. If a sum of the event is happening, if it is possible, then it is success. Otherwise, it becomes failure. So probability deals also success and also failure. So actually, what is originally probability here? In our daily life, when we are not sure happening an event, they use the word probably. So today, probably there will be a rain, and probably he will win the match. So these are probability. That is a chance. We don't know what is the prediction value. So that is probability. Okay. So a measure of uncertainty is provided by a branch of mathematics that is called theory of probability. Some important formulas. What is that? Is some important facts and formula. Here, experiment. What's the meaning of experiment? An experiment is defined as a process for which the result is well defined. So that is an experiment. So what is a random experiment? Random experiment which is possible outcomes. Outcomes are known, and we don't know what is the prediction of that one. That is called random experiment. For example, rolling unbiased dice, but we know what is the result. We don't know exactly. And tossing a pair of coin. So suppose when you toss a single coin, it has a two-sided head and a tail, but we don't know which one is happening. And drawing a card from a pack of 52 cards, so we take one card, so but we don't know what is exactly that card. So and picking a ball of a certain color from a pack, so that this everything is a random experiment. Okay. And next is some more details for this. When you throw a coin, in a coin there are two possible. One is head, another is tail. In a dice is a solid cube having 6 faces marked 1, 2, 3, 4, 5, 6 respectively. So when we throw a die, the outcome is a number that appears on its upper face. Suppose when you take a card, 52 card, from the 52 card, it has 13 cards in each suit, namely spades, clubs, hearts, and diamond. Okay. So cards of spades and the clubs are black cards. Cards of heads and diamonds are red cards. There are 4 colors in each suit. So here in the cards wise, there are as, king, queen, and jack. So these 4 categories are called face cards. Okay. So next we have so first we define what is sample space. So from this probability we start. Sample space. Sample space, the possible outcomes of an experiment, that is sample space. For example, when you toss a single coin, what are the output? Head and tail. So these two are sample space. So when you toss 2 coins simultaneously, what are the outcomes? Head, tail, head, tail, tail. So these 4 are outcomes. These 4 are called sample space. So when you throw 2 dice simultaneously, what are the outcomes? First die shows 1, second die shows 1. So 1, 1, 1, 2, 1, 3, 1, 4, etc. 1, 6. And 2, 1, 2, 2, 2, 3, 2, 4, etc. 2, 6. And etc. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, etc. This everything is sample space. Okay, next. We go to so now we have some of the definitions of what's the meaning of events and what are the various type of events, the definition of events and its classifications. Now what is the event? In a random experiment, each possible outcomes is called an event. Already we know what is a random experiment. from the random experiment, every possible outcome is called an event. So thus an event will be a subset of sample space. It is denoted by either E or A. Okay, right. So here now we discuss some of the different types of events. The first one is equally likely events. What is equally likely event? Suppose A is one event, B is another event. Suppose the chances of these two events are equal, then it is called equally likely events. Suppose when you toss a single coin, where the possible chance either head and also tail, but not in both. The chances are first, if head is appear, the tail is not there. If tail is appear, the head is not there. So the chances are equal. So this type of events are called equally likely events. Next, favorable event. So what is favorable event? The number of outcomes which results in the happening of the desired events are called favorable events. In this event, suppose when you toss a single coin, if you want the head, suppose if a head is appear, that is our favorable event. Okay, that's all. Next, impossible event. So impossible event means the event does not happening. In an experiment, is an event has the scope to occur is called there is no scope to occur is called the impossible event. Suppose when we toss two coin, but we expect three heads, it is impossible. So these kinds of events are called impossible events. And next. Next we have this mutually exclusive events. What is mutually exclusive events? The two or more events cannot happen simultaneously. That is mutually exclusive events. Suppose we take the same example. When you toss a single coin, if head appears, tail doesn't there. If tail is there, head is not appear. But these two events not happening at the same time. Therefore, A is the event of head, B is event of tail. What is intersection? Intersection means a common of A and B. A is head, B is tail. There is no common for a single tail. Therefore, the case becomes is pi, that is empty set. The A is head, B is tail. There is no common. Therefore, it is empty. So, any two events, if the intersection is empty, then that two events are called mutually exclusive events. Okay. Now, independent events and dependent events. Independent events. Suppose A and B are any two events. The event A does not affect the event B. That is called independent event. So, what is the meaning of independent event? Suppose A is the event of, take a card. Suppose you consider we draw a single card from a pack of 52 cards. That is event A. So we take one card from the 52 cards. So it is selected from 52 C1 base. Why it is C1? It's a combination because we don't know where is that one card. It is in first draw or second draw or third draw or some 51st draw or 52 draw. We don't know. Therefore we have the combination. So among the 52 draw, we take one card. So 52 C1. So 52 C1 is also 52. And B is another event. We take one more card. So before that, the selected first card was again replaced in the pack. Okay. Now the total number of cards are 52. So let B be the event of, we take one more card. So it is selected from 52 C1 base. The answer is 52. In both cases, we take one card, but result is also 52 and 52. If in this second event we take one card, that result is not affected in the A, or A is a one card. A is the event of selected one card. If you select one card, that event is not affecting the B. So total the same result is shown. Okay. Therefore, the event A does not affect event B. Therefore, this kind of events are called independent event. So next, what is dependent event? Depend. So the event A affects event B. That is, the result is one result is dependent on the another result. Suppose A and B are any two events. So take that same example. A is the event of one card, taking one card. It is selected from 52 C1 base. That is 52. So it is event A. And after selecting that, the selected first card was not replaced. Now the total number of cards are 51. Okay. Let us consider B is another event. That event is also taking one more card. So one card. So main condition is that the selected first card was not replaced. Okay. Now the total number of cards are 51. So from that we take one card. So it is selected from 51 C1. The result is 51. But in both case, we choose only one card. The first event, the result is 52. Second event, we take one card, the result is 51. Why this variation? The selected first card was not replaced. Therefore, the total number of cards in the event B, it is 51. So 52 and the result is also 51. Therefore, the result of B is depend on what? Depend on the result of A. So this kind of events are called dependent event. Okay. Next, exhaust event. What is exhaust event? Actually, what is sample space? Sample space is the possible outcomes of an experiment, that is sample space. Exhaust event is nothing, the total number of possible outcomes of an experiment. Suppose when you toss here, when you toss 2 coins simultaneously, the sample space are HH, HT, TH and TT. So these are all the sample space. Now we count what is that? N of S. What is N of S? Suppose we take here the N of S is we take what are the possibility? 1, 2, 3, 4. There are 4 possible. So this we count the result directly. It is called exhaust event. So exhaust event is the total number of possible outcomes of an experiment. That is exhaust event. But sample space is only possible outcomes. Exhaust event, total number of possible outcomes. What is the difference of this sample space and exhaust case? Sample space is we visualize what is the result. Exhaust case, we don't know what is exact visualizations, but we take only the number of possibility. So that is the main difference. Okay. So all these things we define what is probability. So we have a lot of definitions or various definitions of event. Before that, what is sample space, what is exhaust, what is different type of events, favorable event, independent event, dependent event, equally likely events, and exhaust events. Everything is also event. So how we apply all this? So what is probability? So definition: probability of occurrence of an event. It is probability. So what is that? Let S be the sample space, A be the any event. So already we know A is subset of S. And what is probability of an event A is number of outcomes favorable to E or some it is A. So not it is E, it is some A. And total number of possible outcomes. So number of outcomes, favorable outcomes, that is N of A. Total number of possible outcomes, that is exhaust event, that means N of S. So N of A by N of S, that is the formula for probability. Therefore, probability for certain event A is equal to number of favorable case divided by total number of possible case. So it is a formula for probability. Okay, so what are the axioms of this? The probability of sample space is always 1 because the probability value lies between 0 and 1. If the event is not happening, the probability value is 0. If the event is happened, the probability value is 1. So probability value lies between 0 and 1. And the probability of sample space we have the complete result. So what is probability of sample space? Its value is 1. Probability, suppose pi is an impossible event. The probability of impossible event is 0. Why? Pi is impossible event. Impossible event means the event doesn't happen. So what is probability value? Probability value becomes 0. Therefore, the probability value lies between 0 and 1. Suppose we have A is certain event and A complement, that is complement of A is uncertain event. So probability of certain event and probability of uncertain event, sum of these two become 1. Why? Probability of certain event value is 1. Probability of uncertain event value is 0. So 1 plus 0 is equal to 1. Therefore, probability of certain event is probability of certain event plus probability of uncertain event value is 1. From this we define what is probability of certain event. Probability of certain event is 1 minus probability of uncertain event. Or what is probability of uncertain event? That becomes 1 minus probability of certain event. From this we define these two cases. Okay. So we give a lot of we give the introductions about this probability and what is event and what is the different types of events and how to define the probability. That's axioms. What are the axioms involved in the probability? We discuss briefly in these sessions. So in the next class we have some of the problem based on this probability. Thank you.